Modeling resistors in AC circuits really is not too bad, because when we talk about resistors, so I'm drawing part of a phasor diagram here, the max current and the max voltage across the resistor are in phase with each other. That means if we draw a graph, this time we're going to put time down here, and we're going to put current and voltage up here. Let's see if I can draw this evenly. So this would be our current, so you would have your peaks be I max, negative I max. And your voltage is going to or this would be VR here, this would be negative VR. And so they're going to vary sinusoidally, or it's really cosinusoidally, but cosinusoidally is not a word apparently, in phase with each other, where they're hitting their maximum values at the exact same moment. So we're going to say that the current and the voltage across the resistor are in phase with each other. So the voltage across the resistor is going to equal the maximum voltage across the resistor times the cosine of the angular frequency of the circuit times T. So you can use this equation to find the voltage across the resistor at some time T. And going back and applying Ohm's law, the voltage across the resistor is equal to the current times the resistance.